Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 7, Lesson 6. Factoring a quadratic trinomial when we have a coefficient in front of the quadratic term that's not equal to 1. For the exploring reason, we have this diagram of a photo of this roller coaster, and we can see one of the dimensions is x plus 4, and then we know the total area is x squared plus 7x plus 12. Can we use that information to find the other dimension of this image? Well, yes. We're just going to factor this trinomial and find the other factor. So we know if we would factor this, break it into our two binomials, break apart x squared into x and x. Then we're going to look at the constant. What are factors of 12 that will also add up to give us 7? We know one of the factors is already 4, so 4 times what gives me 12? 3. If I add 4 and 3, do I get 7? Yes. And since it's plus 12, it's going to be positive 3 and positive 4. So then our other dimension is going to be x plus 3. Write 3 possible lengths and corresponding widths of the screen by substituting values for x. So then you can just pick values for x. If x is 2, then the length would be 2 plus 4, which is 6, and the width would be 2 plus 3, which is 5. Okay, so that's pretty easy. Why would the company use an expression to represent the area? Well, the area of the image could change depending on the device, whether it's on a phone screen or a tablet screen or a computer screen. So maybe they want to have different options for the size of the image. So how is factoring a quadratic trinomial with that coefficient, that leading coefficient, similar to factoring when there's no coefficient? So it's just like we've been doing, we just have one extra step. So you can see here in our trinomial, we have that leading coefficient. We have a value in front of the first term. And so we need to pull that out first, like a greatest common factor. So looking at the numbers, 3, 15, and negative 18, we're going to pull out the greatest common factor for those 3 terms. So we can pull out a 3 in each of those. Okay, so that's a common factor. And looking at the x variables, they all have at least one x. So we can pull out one x. So the greatest common factor for that trinomial is 3x. So if we pull that out, and then what's left inside the parentheses? So again, just do reversed distributive property. 3x times what gives me 3x cubed? Well, I need 2 more x's. 3x times what gives me 15x squared? Well, 3 times positive 5 gives me 15. I have 1x. I need 1 more x. 3x times what gives me negative 18x? So 3 times negative 6 will give me negative 18, and I already have my x. So then we have this trinomial inside our parentheses. Can we factor this? Yes, this is what we've been doing before. So we're going to now do that, and so we're going to break apart the single parentheses. Don't forget to keep the greatest common factor out front, but now we're going to break that into 2 binomials and factor the same way. X and x. What are factors of 6? Negative 6, that give me positive 5. Well, it's going to be positive 6 and negative 1. And now this is fully factored. Okay, we have fully factored it. The previous step here, we've just taken the greatest common factor, but it's not fully factored. Try it number 1, factor each trinomial. So as you can see, for each of these, we do have a leading coefficient. So we need to pull that out first. So let's look for a greatest common factor first. I can pull out a 5. So 5 goes into 5, 5 goes into negative 35, 5 goes into 50. And I can't pull out an x because this constant doesn't have an x. So let's just pull out the 5, and then we'll factor. 5 times what gives me x squared? Well, 5 times x squared. 5 times what gives me negative 35x? I need to multiply it by negative 7x. And 5 times positive 10 gives me 50. I have one more step. I'm going to then factor the trinomial in this parentheses, so I will break it up into x and x. Looking at our constant, what are factors of 10 that will also add up to give me negative 7? Probably going to go with 5 and 2. but I have to have a negative, so then these both need to be negative. If I do negative 5 times negative 2, I get positive 10. And if I do negative 2x plus negative 5x, I do get negative 7x. Okay, letter B, we're going to factor out a 6. And they each have at least one x, so I could pull out a 6 and an x. Then we're going to write the rest of the trinomial inside parentheses. So again, reverse distributive property. 6x times x squared will give me 6x cubed. 6x times 5, positive 5, and one more x, because I have x, I need 2. And 6 times positive 4 gives me 24, and I already have the x. Then we're going to break that trinomial into 2 binomials and factor one more time. X, and 4 and 1 will give me positive 5. Example 2, understand factoring by grouping. So here's another method to do factoring. We can regroup things together, group the like terms together. It's just writing the distributive property. So we have this product, we have 3x plus 4 and 2x plus 1, and we're just going to regroup things. All we're doing is we're doing the distributive property. So first we're going to distribute the 3x, and so that's what we get there. And then we're going to do the 3x to the 1, that's what we get there. And then we're going to do the 4 times the 2x, that's what we get there. And then 4 times 1, that's what we get there. So this is also sometimes called the FOIL method. FOIL. You do the first term, then you do the outer term, okay, the 2 outer terms. Then you do multiply the 2 inner terms, and then you do the last. Okay, so this is first, outer, so you multiply the 2 outer terms, then you multiply the 2 inner terms, and then you multiply the last terms. So if you want to remember this acronym, this might help you just to do the distributive property, just like we do with the double arrows. So notice in the step before the final product, the coefficients of the x terms, 3 and 8, add to form 11. So what it's pointing out here is once we've regrouped and we've done the first, so I multiply the coefficients and I get the leading coefficient. And then when I multiply the outer coefficients, I get the linear term. And then I multiply the inner coefficients, I'm still getting a linear term. If I combine those, I get the final middle term. And then multiplying the constants, obviously is going to get you the constant at the end. If this trinomial is the product of binomials, notice we have a coefficient in front of our quadratic term, and we have a constant with no variable. There is a pair of factors, a times c, that will have a sum of b. So you could do a times c, which is just your outer, and then that'll give you a sum of b. How can we factor a trinomial? By grouping. So here's our trinomial, 6x squared plus 11x plus 4. Identify a, b, and c. So a is the coefficient in front of x squared, b is the middle term, and c is the constant. So identify those. So again, this is A, this is B, this is C. And then you're going to just do A times C. What do you get? A times C, 6 times 4 is 24. And then you factor that number. You find factors of that number. So what factors of 24 will also add to give you B? So this is our puzzle that we were solving before, and we're just now incorporating the coefficient in front of the first term. That's all. So we multiply them together now. Before it was just 1 times the constant. So we would look at the constant and factor it. Now we're going to multiply it by a, the coefficient in front of the quadratic term, and then factor it. Okay, so it's the same process. We just have one more coefficient to account for. So factors of 24 that will add to 11 will be, of course, 3 and 8. And then you split that. So then you're going to write, so your factors are 3 and 8. Then those become your 2 linear terms, right? And then you can factor each part. So that's, notice what they're doing here. So they have 6x squared plus 3x, and they're going to factor that right there. Pull out a 3 and an x. That's the greatest common factor. And then in the parentheses, write what's left over. 3x times 2x gives me 6x squared. 3x times 1 gives me 3x. So that's what they did there. And then for the other part with the other linear term, they paired it with a constant. And then we can factor that. We can pull out a 4 from 8x and 4. So they pulled out the 4. That's the greatest common factor. And look, they both have 2x plus 1. So that's a common factor, right? It's a common factor. So that's one of our binomials. And then you just take the factors outside the parentheses and group them together for the second binomial. So that's how they're doing that. It's another method for factoring. You multiply AC, then split them apart, and then you're going to group the first term with one of those linear terms and the second linear term with the constant, and then make sure to factor each of those, and then pair up the common factor, that's one binomial, and then pair up the factors outside the parentheses, that's your other binomial. And you can double check it. If we distribute 3x plus 4 times 2x plus 1, if we distribute, we will get our original trinomial. So it's always good to check by distributing. So let's try factoring by grouping. Okay, so first, what do we need to do? We need to identify A and C. So A times C is going to be 10 times 3. It equals 30. Now we're going to factor 30 so that it also adds up to 17. Well, I'm thinking of 15 and 2, right? So those are my factors that will give me 30, but also add up to 17. So then each of those gets an x. Those are my two linear terms. Because if I do 15x plus 2x, I get 17x. And now I'm going to pair the 10x squared with my 15x. And then I'm going to pair my 2x plus 2x with the constant. And now I just need to factor each of these parentheses individually. So 10x squared plus 15x. I can see that they each have an x I can pull out, and they each have a 5 I can pull out. Greatest common factor is 5x. 5x times 2x will give me 10x squared. 5x plus 3 will give me 15x. Okay, and the other one, 2x plus 3, that's already factored. So look, there's my common factor. Okay, and since this coefficient would just be 1, right? So then I'm going to have 5x plus 1. Remember, I'm going to match up my greatest common factors outside the parentheses. I pair them up together in one binomial. And then I have the common factor. The common binomial, I'm just going to write that. So now that's fully factored, and we did it by grouping. Okay, let's try part B. Identify A and C. So A times C is going to be 2 times negative 21. AC is going to equal negative 42. So now we're going to factor negative 42, and it needs to give me a sum of 1. It needs to give me a sum of 1. So negative 42, it's going to be pretty close, right? 7 and 6, they need to be one away. So our factors will be 7 and 6. One of them needs to be negative. Well, then our 6 needs to be negative. Okay, then they each become a linear term. And then we're going to take our coefficient in front of we're going to take the first term and pair it with one of those. So 2x squared plus 7x, group that together. And then we're going to take our constant and pair it up with the second linear term. So this will be negative 21. And then we're going to factor each binomial. 2x squared, they both have an x, so I can pull out an x. And I'll have 2 plus 2x plus 7. Okay, and looking at negative 6 and negative 21, I can pull out a negative 3. So then I'd have positive 2x and positive 7. Okay, that works because I have 2x plus 7. That's my common binomial. So I'm going to write that down. How do I get my other binomial? What's going to go in the second set of parentheses? Take the coefficients, or the greatest common factors outside the parentheses, x minus 3. And if we check, we can check by distributing. X times 2x is 2x squared. X times 7, that's positive 7x. This is minus 6x and minus 21. Yes, that would give me 2x squared plus x minus 21. That's my original polynomial. So we did factor it correctly. So here's your final answer. So again, you can choose a method that works best for you. If you want to just think backwards, distributive property, you can do that. Or if you want to try this grouping method, this can work also. So what is the factored form of 2x squared plus 7x minus 15? Okay, so we're going to first look at A and C. It's going to equal negative 30. And then we're going to break apart negative 30 so that it adds up to give us 7. So it could be 3 and 10, some combination, but one of them needs to be negative. So that means my 3 needs to be negative and my 10 is positive because 10 minus 3 will give me positive 7. Okay, so there's our factors. And then each of those becomes a linear term. I'm going to move it on over here. 3x and 10x, and then pair up the first linear term with the first term, the quadratic term. So I'm going to have 2x squared. We're going to factor that, and then pair the constant with the second linear term, so it'll be minus 15. We're going to factor that. Okay, I can see in the first binomial, 2x squared minus 3x, I can have an x come out as my greatest common factor, so that would be 2x minus 3. And for my second binomial, 10x minus 15, they both have a 5 I can pull out, and yep, sure enough, I do get 2x minus 3 as my common binomial. So then I will write that down. 2x minus 3 is one binomial. What's the second binomial going to be? I'm going to take my greatest common factors and combine them. Just watch your signs. If this is positive, it's going to be plus 5, right? So there's the factored form of that trinomial. All right, I'm going to do both methods for this one. I'll do the regrouping and then I'll do the reverse distributive property to practice either method, whichever one you prefer. Okay, for part A, let's do the regrouping one more time. So I can see, what is A times C? A times C is going to equal negative 24. I need to break apart negative 24 to give me 5. I'm going to think 8 and 3, right? So 8 and 3. One of them needs to be negative. Which one needs to be negative? The 3 needs to be negative. So then they're each going to be a linear term. And I'm going to pull the first term and pair it with 8x. And then I'm going to take my constant and pair it with negative 3x. Then I'm going to factor each binomial. For x squared and 8x, they both have a 4 and an x. So then if I factor that, I'm left with x plus 2 in my parentheses. If I factor negative 3x and negative 6, I can pull out a negative 3. And it'll be x and positive 2. That's what I want. I have a common binomial. So I'm going to write my common binomial and then take my greatest common factors and put them in the other binomial. 4x, and this is a minus 3. Okay, part B, I'm going to do the reverse distributive property, and I'm going to show you this method, and you're welcome to try this. It's got a little bit of trial and error, and you'll see what I mean. So first, I'm going to just set up my two binomials. Okay, I know my factored form is going to have two binomials, and I'm going to start with factoring my first term. So I'm going to break up 3x squared. I know it's going to be 3 times 1, and then x times x. Normally, when we've done this, it's just been x times x. But I have to remember I've got that coefficient 3 in there. That's going to come into play when we factor the constant. So now let's think of factors of negative 8 that would also, after one of them is multiplied by 3, I would get a sum of negative 10. So this just takes a little bit of trial and error. Factors of negative 8. Let's start with 4 and 2. I know one of them needs to be negative. So let's just start here. Positive 4, negative 2. If we distribute, I'd have 3x times negative 2. That's negative 6x. And then I'd have positive 4x. Does that give me negative 10? No, it gives me negative 2. Okay, have no fear. We can switch things around. But if I switch the numbers, and 2 goes here, and 4 is paired with the 3, that might work. Okay, So now I need to figure out which one is going to be negative. Well, let's just try this. 3x times 4, that's positive 12x. Minus 2x, that gives me positive 10x. Okay, we're so close. We've got the right number. We don't have the right sign. So that means we need to change the signs. Positive and negative. Let's check. 3x times negative 4 is negative 12x. 2 times 1x is positive 2x. That will give me negative 10x. And there you've got your factored form. So this method you can still do. If you don't like the regrouping, that's fine. It's just going to take a little bit of trial and error, changing numbers around. Make sure you change your signs. And make sure to always double check with distributing. Example 4, here's a trinomial with a coefficient of 15 in front of the quadratic term. Let's factor it. So the first thing they did was they looked at the coefficients and they said, hey, we can factor out a 5. So they pulled out the 5 and then did the reverse distribution to get another trinomial. And now we can factor this by grouping, because look, we still have a 3 there, right? So we can think, what is A times C? A times C is 24. Break apart 24 so that it adds up to negative 14. And so 6 and 4, I've got 6 and 4. I don't think I can get 14 out of there. 2 and 12, I can get 14. So which one needs to be negative, or they're both negative? Because negative 2 times negative 12 will give me positive 24. And then I add them up together, I will get negative 14. So they're going to be the negative versions, the negative factors. Okay, and then remember, they each become a negative or a linear term, so I'll have negative 2x and I'll have negative 12x. Pair up the first now. What is important is we're working with inside the parentheses. That's all we're doing. All we're doing is inside the parentheses. So do not forget, do not lose that 5. Do not lose that 5. So I have a 5 out here, okay? And you could do brackets or just lots of parentheses. Okay, so I'm going to pair up my 3x squared, okay? And then I'm going to pair up, move this over a little bit. I'm going to pair up my constant, which is positive 8. Okay. So again, don't forget you're working inside the parentheses, so it's important that you're writing this down. You can see they do a very nice job here. They're just writing a new line every time, and they're not forgetting the 5 out in front. Then we further factor 3x squared minus 2x, and we get x minus 4 and times 3x minus 2. Double check by distributing. Whenever you get to your final factored form, double check by distributing. So you're going to do x times 3x is 3x squared. X times negative 2 is negative 2x. Negative 4 times 3x is negative 12x. Negative 4 times negative 2 is plus 8. And then don't forget to multiply by 5 all the way through. So then we get 15x squared. Then that's negative 14 times 5 is negative 70x. And 5 times 8 is positive 40. Did we get our original trinomial? Yes, we did. So when you have to first factor out a greatest common factor and then regroup your trinomial, do not lose that GCF on the outside. Write it every time. So let's factor these trinomials. So first, I'm going to look. I think I can pull out a greatest common factor. I can pull out a 4. So I'm going to pull out a 4 and then rewrite my trinomial. 4 times 2x squared. 4 times negative 5x. 4 times negative 12. Now I'm going to factor inside the parentheses. That's it. I'm just factoring inside the parentheses, but I'm going to rewrite the 4. And now I'm going to factor AC here is negative 24. Factor negative 24 to add up to negative 5. So let's see. Let's break it up into 8 and 3. And probably needs to be negative 8 and positive 3. They each become a linear term. Okay, and I'm going to pair up negative 8x with 2, so I'm just looking inside the parentheses now. 2x squared, that's my one binomial. Put the constant with the other linear term. Okay, now I factor even more. I can see I've got a 2 and an x in there. So what's left? X minus 4. And I'm going to factor my second binomial. I can pull out a 3, and I've got x minus 4. There's my common binomial. So then I'll have x minus 4 as my binomial, and take my GCFs and put them together, 2x plus 3. What did I forget? What are you not supposed to forget? Don't forget your 4 in the front. Okay, so don't forget to always put that greatest common factor back. Okay, let's do part B. And this one I'm going to do the other method. I'm not going to do regrouping. I'm just going to try to factor and figure it out using the reverse distributive property. So first, is there a greatest common factor that I can pull out? Well, they're all even, so I can at least pull out a 2. Rewrite it. I've got 3x squared. I've got negative 26x, and I've got positive 35. Okay. Now I've got to factor only inside the parentheses. I'm only factoring inside the parentheses. I'm going to not lose my GCF on the outside. Okay, but now I'm going to just set it up into my 2 binomials right now and try to factor it. So break apart your first term, 3x and x. Now I'm going to take my constant and I'm going to break it up. Something times something also adds to negative 26. But remember, one of them is going to be multiplied by 3. Okay, so 5 and 7. What if I did a 7 here and a 5 here? I'd get 21 and 5. I think that can get me a 26. Because 3x times 7 would give me 21. And the 5 times the x would give me a 5. So let's figure out. They're both going to be negative because that linear term is negative. Let's double check. 3x times negative 7 is negative 21x. And negative 5x, negative 5 times negative 7 will give me positive 35. Okay, so negative 21 plus negative 5 is negative 26x. Okay, so here's my factored form, my completely factored form right there. I was able to figure out the numbers on the first try. Made it to the concept summary for factoring trinomials when you have this leading coefficient in front of the quadratic term. Okay, so a couple ways you can do it, but you want to make sure you're always double checking your work at the end by distributing. And do not forget to keep writing that greatest common factor for every step you do if you're doing the regrouping method. Okay. If you have any questions, put them in the comments. Make sure to like and subscribe and come back for lesson 7.